I am going live for KOG live homework help. It's going live on Facebook also, and we should be getting started soon. Second, please. Okay, great. Hello. Welcome everyone to the KOG live algebra homework help. I do these every Thursday at 8 p.m. I'm going to write the title. Oops. The live. All right, and I'm here to answer your questions. Any questions you may have. On your math homework. I'm just gonna, okay, so I'm live. Just making sure I'm live. Any questions you may have on math homework, on any study questions that you're working on. I am here until for 30 minutes if you don't have any questions, and for an hour if you do. So I'm just gonna share this real quick. Who's watching? Give me a hello if you're watching now. I see you. I'm just sharing my live session. Oh, Miss Michelle's watching. How are you? Got any questions, Michelle? Somebody else jumped on. I'm here available to answer any questions you may have. Miss Army Jackson hopped on. We got the same last name. So I did have someone ask me a question about exponents. And let me just get that question. Oh, that was someone else. That was another question. But here's a different question that I'd like to go over, and just in case anybody doesn't have any math questions they need help with. Let me get my computer, which is right here. How's everybody's week been so far? I've been busy as always, just trying to get myself together. And oh yeah, I forgot to tell you guys, I have a resource library that you guys can become free members of and get like free downloads, free study guides, cheat sheets, and what else do I have? I got my free course in there that you can sign up, but everything is in one place. The top 7 concepts you must master in order to pass algebra is in there. I got the challenge in there. The champs at word problems challenge. So in the description of this video, you can click it and become a free member of the KOG Math Success Library. And I would love for you guys to go in and see what you can use, how you can be helped. Just trying to get everything set up. It's always a process. Okay, so here was a question that someone, sorry that I'm late, by the way. Here's a question that someone left for me, and I told them I'll answer it during the, when we go live. And it is, it's actually translating algebra, translating verbal expressions to algebraic expressions, translating to, and honestly, this is one of the days in the Champs at Word Problems Challenge that I had going on a couple weeks ago, where we were practicing translating, and I had actually have a table or a guide to help you to see like which verbal expressions match which pre-algebraic um, operations, like addition, subtraction, multiplication, division, equal. So let's try some. So let's try this one. It says 2 times a number more than 7. 2 times a number. So we got 2 times number. Okay. 2 times a number. So number. Okay. So let's call this a number n. That represents some number that we don't know because that's 2 times a number more than 7. So we're just going to call that number n. And then let's look at what's happening to that number. It says 2 times that number. So 2 times that number will do n. 2 times a number, 2 times n. And if, say, if we had 2 times 5 more than 7, 2 times 5, that would be 5, right? So since we don't just have 2 times a number, we're gonna call it 2 times n. More than 7. So what kind of word is more than? Get that chart too. More than is an addition word. More. So if you have a bottle of water and your coach comes in with 10 more bottles of water, then that means your coach has more than you. You have your bottle and your coach has 1 bottle plus more. So more than is an addition word. 2n plus 7. So that's a little bit of that's one example of translating a verbal expression to an algebraic expression. Let's do 3 times a number added by 5. Let's do 3 times a number added by, okay, 3 times a number added by 5. 3 times a number added by 5. Okay. So 3 times a number added by 5. A number added by 5. Sounds like a number added by 5 is going to be sectioned off. So we can call a number n again, added by 5 plus 5, right? And we're going to do 3 times a number added by 5. So that means that we actually want to section this off in parentheses and put 3 outside. 3 times a number added by 5. Cool. Thanks for hopping on. If you're watching, please give me a heart. I would love that. We're doing some verbal translation, verbal to algebraic. Okay, so let's look at some other ones. Let's look at a more difficult one. The sum of three, all right, the sum of three consecutive integers. The sum of three integers. Consecutive integers. Okay, so in this situation, we got to break down some words, some vocab words. Sum first. What does sum mean? That means that we've added numbers together. That the sum is the result of adding the result. So let's say we added plus 7, right? The sum, that's okay. Consecutive. Consecutive means one after the next. After consecutive. So consecutive in numbers would be like 1, 2, 3. Those are the first three consecutive numbers, right? 1, 2, 3 are one after each other. And then integers. An integer is a number, a whole number, basically. An integer is a whole number and its negatives, including 0. So we got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to infinity. And then we have the negative version of those numbers. So that can look like this. If we had a number line, let's not do number line. Let's do -3, -2, 1, 2. Those are integers. We're not looking at fractions. We're not looking at decimals. We're just looking at whole numbers, 0, and their negatives. Okay. So the sum of three consecutive integers. Now we have a better understanding of what this question is asking us to do. We're trying to translate it into an algebraic expression. The sum. Okay. So that means we're going to be adding. We're going to be adding three integers consecutively, but we're not thinking of like a specific number. We're thinking of um any number really. So the sum of three consecutive integers, we can say, let's use x. Let me do a different color. Yep, let's use x, right? X is the first number, the first integer. Okay. um let's, for instance, let's see if we can plug in a number to try to get to the next consecutive number. Because yeah, we're working with x, but we want to make sure this works. We want to make sure whatever rule we come up with actually works. So let's say x equals 1. All right, we have integers, so that means we want the next one, because we want one after the next. We want the next number. So if we have x, how do we get, if we have x and x is 1, how do we get to 2? How do we get to 2? We add 1. Add 1 to 1 to get 2. And what is 1 equal to? 1 is equal to x. So we're going to add x plus 1. Okay. Let me know if you have any questions on this because when I was learning this, I didn't get it that well. I didn't really understand what was going on. X is 1. X plus 1 is 2 because we're adding 1 to get the next number. What do we have to do? Third number, 3. We got to add another 1. We got to add another 1 to 2 to get 3. But what did we do to 1 to get 3? We had to add 2 to get 3, right? And 1 is x, so we get 2. That gives us 3. So x is the first one. X plus 1 is the second number, consecutive integer, and x plus 2 is the third consecutive integer. So how can we write that an expression? We can say x plus parentheses x plus 2. And those are three consecutive integers. If x equals 1, then x 1. If x equals 1, then oh sorry. If x equals 1, then x is 1 here. If x equals 1, then x, we plug in for x, plug in 1 for x, and add that to 1, we get 2. And then if x equals 1, we plug in 1, 2, what do we get? 3. So actually what we want to do is add because we want the sum, right? We don't need to add these because we're actually not looking for 1 plus 2 plus 3. We're just looking for which we knew it can be any number. We would add this all together. But since we don't know what x is, this is the sum. And in the box, that's the sum. Let me charge my computer. Anybody have any questions? Appreciate anybody who hopped on. Okay. Let's do another one. Thumbs up. If you get thumbs up. Some translating, what we're reading when we're doing math. Um, I'm going to do one more and then I'm going to address a topic that somebody asked me about earlier today. So let me see. This one says 8 times 9 decreased by a number. 8 times 9 decreased by a number. Eight times 9 decreased by a number. 8 times 9 decreased by a number. So 9 decreased by a number. That's where we're going to start. We know that 8 is actually being multiplied, that 9 decreased by a number. So what is by a number? How does that look? Expression? We got 9 and we're decreasing it. N. 9 minus n. 9 is 9 is being decreased. Let's say 9 was 2, right? If it was I mean, let's say n was 2. So if it was 9, is it 9 being decreased by 2? Because 9 minus 2 is now going to be 7. So 7 is less than 9. So if 9 is decreased by a number, even if we don't know what it is, it's going to be 9 minus that number. Okay? And 8 times 9 by 9, just have to really try to like read it over and over again and mull it over in your head so that you can try to understand what's actually being said. Okay. Just looking at another question someone had for me. Order of operations. Okay, Miss Latyra wanted to review operations. Let's find some order of operations to work on. And guys, I just want to mention that um, it's not that hard to go online and find worksheets to work on, practice, games, apps. I don't know if you guys seen any of my posts about with the multiplication images, but you can download an app to help you get better with your multiplication facts, because multiplication and division, which is the opposite of multiplication, once you know your multiplication, division is really not that hard. But multiplication is a challenge if you, or I mean, algebra is a challenge if you don't know your multiplication facts. Um, so it's really important to get those mastered. And what better way to do it with a game than with a game? Okay, so let's try some order of operations. Not doing these basic concepts, because these basic concepts are what make up more more complex algebra concepts. Okay, so having these all mastered, like I just said about multiplication, is really important to have this all mastered so that when you get something more difficult, you're not being stuck on the little stuff because you forgot how to multiply, or if you forgot, which order to do your order of multiplication, order of operations, or you forgot how to work on radicals. That's why I have that free course, the top 7 concepts you must master in order to pass algebra. So with order of operations, we always use, and a lot of people um, help themselves to remember it by saying the acronym, please excuse my dear Aunt Sally, but it really stands for please. Exponents, and exponents are also in the same at the same schools. Multiplication, addition. One thing I want to say about multiplication and division is to write. And addition and subtraction, you do it from left to, okay? All right, so let's work on some. We got 12 Okay, this is like level 1. 12 plus 3 times 4, going from left to right. Well, actually, let's look at the order of operations and see what we see in our expression. So we got parentheses. I don't see any parentheses. Exponents and radicals. I don't see any of those. Multiplication is next. I do see multiplication. 3 times 4, 12. Then we can our other 12 down. And division, we don't have any. Addition, yes. 12 plus 12. Cool. Let's do another. Let us try 10 plus 30 divided by 2. Okay. All right. Parentheses, none. Exponents and radicals, nope. Multiplication and division. I see multiplication, but it's actually after division. And remember, we go from left to right. Go left to right. So we're going to do division first. Okay. 30 divided by 2. Because this is, remember, this is the left. Start over here towards the right. 30 divided by 2, that is 15. So bring our 10 down and multiply by 3. Now, when we're going down the um, acronym again, parentheses none, exponents none, but we do have multiplication. 15 times 3, that is 40. 10, bring that down. 10 plus 45, that's the last thing to do. So we just go ahead and add 55. Anybody got questions? I haven't been on the screen. Okay, let us do another. Let's do another one. Actually, I like that arrow. Let's do a more complex one. Negative 3 minus negative 2. 8. Okay, this has a lot to it, a lot going on. And at this point, I will say that it's really important to understand your integers and the rules to adding, subtracting, multiplying, and dividing integers. With my students that I tutor, they really get the multiply and divide rules of integers mixed up with addition and subtraction rules of integers. And I always have to correct them. But if you take that free course that I have, the top 7 concepts you must master to pass algebra, there is a module with integers there that you can watch a video, a tutorial of me working through the rules. You got a text version of the lesson. You have practice problems that you can do and a quiz that you can work on so that you can test your knowledge. Okay. All right. So let's work on this one. Parentheses. So yes, I do see a bunch of parentheses. I got something in my eye. Sorry, I do see a bunch of parentheses. But in this situation, parentheses are they're just around the numbers. They're not around an operation. So in that case, we're going to disregard the parentheses here, and we're going to move on to exponents because I do see an exponent. And the number that is being exponentiated is 5. So what's being exponentiated is 5, not 3. Not 3 times 5, just 5. So we got 5 squared, and then, okay, I'm going to write the rest of everything else. Take a sip of water. Actually, that was tea. Um, okay. So what's next? Parentheses, exponents, no exponents, multiplication. There's a lot of multiplication in this problem. So let's look at the first from left to right. Left, right. Let's look at the leftmost multiplication instance, and we got negative 3 times 25. Negative 3 times 25. So we got a negative times a positive. And what's a negative times a positive? Also, 3 times 25 is actually 5. Okay? And let's just go ahead and anything else down and start over with our acronym, parentheses, exponents, multiplication. So we got multiplication, and we got negative 2 times negative 8. Now in this situation, we have a negative times a negative, and negative times negative gives us positive. Okay, so we know that our answer is going to be positive. Let's put parentheses. And 8 times 2 is 16. Okay, now 5 minus positive 16, so we're just going to put that 16 outside of the parentheses. So what's next? Parentheses, exponents, radicals, multiplication, division, addition, no addition, we got subtraction. All right, so we got negative 75 minus 16. Now, are using the number line. Let's say we start at negative, that's what's happening. We're minusing, we're subtracting. So we actually go into the negative direction is this way. It's towards the left. We always go to the left when we're subtracting, even if we're in positive numbers, even if we're on the positive part of the number line, we always go to the left when we're subtracting, and when we're adding, we always go to the right. And remember, I explained this in the course. So starting at negative 5, and we're subtracting 16. So we're going to the negative towards the left, 16 more units. Okay, so I don't really want to use my calculator. I'm going to see if I could do it by by memory. So I'm going to break this up. I'm doing negative 70, 10, then minus 6, because 16 is made up of 10 and 6, right? All right, so let's do negative 75 minus 10 first. So negative 5, right? Remember, as you go negative, you kind of go high up in the negative world. So it looks like you're getting a bigger number, but you're actually getting a smaller number because you're going more and more negative, more and more away from positive numbers. Okay, and then you start to, okay, these are all, but we're in a negative. We're in a negative world. So we subtract, that's minus 10. Now we're going to, okay, negative 80. So we're actually adding, right? It looks like we're adding negative 70. So 75 plus 10 is 85, right? But negative 75 minus 10 is negative 85. So in order for us to get the last portion, we can add and then just make that answer negative. So 85 plus 6, 85 plus 5, even make it even a little more easier. Melanie, hello, Miss Melanie. Just doing some order of operations. Because 6 is made up of 5 and 1, and it's easy for us to count in fives, easy for us to count in ones. So negative 75 minus 10 is negative 85. Negative 85 is going to be negative 90, and then negative 90 minus 1 is going to be 1. And so that's your answer. 1. Okay. Anybody have questions? Melanie, do you have a question for me tonight? Let's try another one. See, this is with a rule, and that will help you to be successful in solving these problems. Let's do one with radicals. Okay, so we got -7 minus negative. Okay, so what do we do first? Go to our order of operations list. Operations, ooh, and we start going down the list. Parentheses, I do see parentheses, but once again, there's only one value in the parentheses, so we're going to disregard that for this problem. Exponents, don't see any exponents, but I do see radicals. It should be perm des. Now that I'm thinking about it, perm des. I'm gonna make that a new thing because multiplication and division is left to right, addition and subtraction is left to right, exponents and radicals should be left to right, but it doesn't really have to be. But it is important to include radicals in PEMDAS. So we're going to address our radical. Square root of 36. Square root of 36. And let's write the rest of the expression. Now we're going from left to right again. Parentheses, exponents, radicals, multiplication. Left to right. So we got -7 times 6. Negative times a positive is a negative. So we're going to do negative 7 times 6 is 42. Whatever number is inside these, let's put brackets around these. Multiplication right here. -2 times -3. Well, we're doing our multiplication. Let's follow what I was doing before and go to the next, go to the next, go through the list again. We have parentheses, we don't have parentheses, don't have exponents, radicals, but we have multiplication again, and that is your -2 times -3. So -42 minus -2 times -3, that's going to give us a +6. Okay? Positive. Now we got -42 minus 6. Once again, we starting at 2 and we're going. Subtracting is always goes towards the left. We're minusing 6. 42 minus 6. That can be minus 6. What's 12 minus 6? 12 minus 6 is, sorry, we're not even subtracting. We're adding, because in the negative world you add when you're subtracting a negative number. When you're subtracting a number in a negative world, you add. So we're actually going to be doing 12 plus 6, which will be -12 minus 6. So 12 plus 6 is 18. 12 plus 6 is 18, excuse me. But -12 minus 6 is -18. And I'm just doing this so that the 42 doesn't distract me. The 42 is like a big number, and I don't want that to be a distraction from me being able to get to the answer. But so I kind of what's the word? I kind of water it down to numbers that I'm used to dealing with, like numbers closer to 0. So I see that this number 42 ends in 2. I can bring that down to 12 because it's closer to 0 and I'm used to working with 12. It's a multiple. It's not a multiple. It's not a multiple. But I know that 12 and 6, I can work with that more easily than I can work with 42 and 6. And that's a method you can use. Make sure you go back to the actual number. Once again, negative 12 plus 6 is negative 12. 12 plus 6 is 18. So negative 12 minus 6 is negative 18. And negative 42 minus 6 is going to be negative 48. And adding a negative row really means subtracting. So that's our 48. Okay. One more and we're going to finish up for the day. Let's do a fraction one. Let's do one with fractions. Wow, that's wow. That this one a challenge. So we got 7 minus 6 and plus 3 times 7. Wow. Wow. Okay. You got this. All right. Parentheses. Yes. There is operation going on inside of the parentheses. So let's work on that first. In the parentheses, inside the parentheses, we have to start over with um, the order of operations. So let's start with parentheses again. I don't see parentheses inside the parentheses. I don't see exponents or radicals. I don't see multiplication. I do see division. And let me write this in another color. Divided by 7. Divided by, so that's division. I do see division. However, we can't do the division before we figure out, we simplify what's in the numerator. We got to simplify that first. So this is actually broken up into two parts. We got to do the numerator, then we got to do the denominator. So go through the go through PEMDAS again for the numerator, go through PEMDAS again for the denominator, then you can divide. A lot of parts to it, right? Okay, so we're going to start over with PEMDAS for the numerator. Parentheses, exponents, nope. No radicals, no multiplication, no division, no addition, but we do have subtraction. We got negative 5 minus 9. Let's write negative 5 minus 9 is negative 5. Well, we can do 5 plus 9, which is 14. So negative 5 minus 9 is negative 14. There is still. And now we can do our division. Negative 14 divided by negative 7. Negative divided by negative is positive, and 14 divided by 7 is 2. Okay? All right, so all of this in parentheses is just 2 now. So we can write this again. Parentheses minus 6 over and select. Okay? All right, so this is negative. Once again, we have a fraction. We got the numerator, we got the denominator. So we got to do PEMDAS for each numerator and denominator. Let's do PEMDAS for the numerator first. Parentheses, I do see parentheses, but that means multiplication here. Exponents, radicals, no, multiplication. All right, so let's do this multiplication. We got minus 3 times 2. 3 times 2 is 6. Makes 11 times 7. Okay, now let's start over. No parentheses, no exponents, no radicals, no multiplication, no division, no addition, but I do see two instances of subtraction in the numerator. We got, then let's go from left to right. We got 5 minus 6. 5 minus 6 is -1. -1 minus 6 is 7. Okay? Use your number line to help you with adding and subtracting integers, especially with negatives. So our numerator is simplified completely. Now let's simplify our denominator. Start over with the order of operations. Parentheses, nope. Exponents, radicals, nope. Multiplication, I do see 3 times 7, which is 21. So that minus 11, 21 now. Okay. All right. So let's move this. Actually, we don't need to. I don't think so. So now go through the order operations again. Parentheses, nope. Exponents, radicals, nope. Multiplication, division, nope. Addition, I do see addition, and I see subtraction too. And remember, with addition and subtraction, we're going to go left to right. Left to right. So we start from the left. The left is -9 minus 11. So that subtraction goes first before the addition. So -9 minus 11 is what? What's 9 plus 11? 9 plus 11 is 20. So -9 minus 11 is, and then we still got that plus 21. -20 plus 21, what is that? It's 1. And -7, now we can do our division. That's all we got left. -7 divided by 1, and that's our answer. Awesome. Does anybody have any more questions? I kind of sort of want to do one with absolute value because I have it here and I think that it'll be a great exercise to work on. So let's try it. And we're working with absolute value. So let's write it down, and then I'm going to talk about what absolute value actually is. -3 parentheses absolute value, or times, that would be times absolute value minus the absolute value end divided by 9. Okay, you don't see absolute value in the order of operations too often, actually. So let's see where this actually should go. We should include that in the acronym, right? I think so. Let's figure it out. Okay. What is absolute value, first of all? Absolute value is actually the distance that something is from 0. So for instance, right, that's 0. And let's say we got 2. How far is 2 away from 0? 2 is away from 0. Let's put -2 here. How far is from 0? Distance is always positive. So -2 is also 2 away from 0. So when we're finding the absolute value of a number, 2, that's what that would look like. The absolute value of -2 is 2 because it is 2 units away from 0. That's all we want. We just want to know how far away that number is from 0. That's it. We don't need to know Actually, there's nothing else to know. We would just want to know how far it is away from zero. It don't matter how big or small the number is. It could be negative 65. It's going to be 45 units away from zero. That's it. The same way 465 and 60 zero. It's just on different sides of zero. It's like you take like you're at a tree and you got a rope and you're running around the tree with the rope, and say the rope doesn't like get shorter as you're running around it, like to wrap around it. Let's say you tied a loose knot around or a loose loop around the tree, and you're running around the tree with the rope, and it's loose enough that it can like turn with you, the rope. At each point around the tree, you're going to be the same distance each time. So say I'm the tree and the rope is over here. The distance that it is over here is the same distance that it would be if the rope is over here, or if you were with the other end of the rope on this side. It would be the same distance, right? Same distance. That's the same way absolute value works. It's just the distance that you are away from zero. Got it? So let us I was supposed to get purple. Okay, purple. So let's break this problem out. So we got parentheses. Yes, we do have stuff going on in the parentheses. Um, negative 6 minus 3. Negative 6 minus negative 9. Okay. Times the absolute value divided by 9. Okay, so now I know where absolute value should go. It should go on the same level as parentheses. So I'm going to put that here. Value. Okay, so let's start over at this level, at this step, with the order of operations again. Parentheses, absolute value. I see absolute value times absolute value of negative 2 minus 3. What's that? 9. Okay? Okay. Now, try again. Let's start over with the order of operations. Parentheses, absolute value. I think we need to simplify this absolute value. So what's the absolute value of 5? What does it mean again? It means that it means what is the distance negative 5 is away from 0. How far is negative 5 from 0? 5, right? So once we figure out what that answer is, we no longer need absolute value signs. We don't need those lines, the symbols, because we figured out what they are there for. The 5. That is the absolute value of negative 5 by 9. Okay, yay. Parentheses, absolute value, we have none. Exponents, radicals, none. Multiplication, though. I see multiplication. And remember, multiplication and division is left to right. So we're going to do our multiplication first because that's what we see first in the expression. So negative 9 times 5, well, a negative times a positive is, and 9 times 5 is 45. By 9, that's the only operation left. We got negative 45 divided by 9, and a negative divided by a positive gives us a negative. So and 45 divided by 9 is 5. So the answer is negative. Yay, we did it. Okay. If you have any questions on the replay, please go ahead and ask it, and I will be glad to answer your question for you. Please go ahead and make yourself a free account for the KOG Math Success Library. It's linked in the description of this video, and you'll be able to get access to the top 7 concepts you must master in order to pass algebra, which is also in the description of this video. There's a link there as well. But it goes over the basics you need in order to be successful in algebra, in order to make it smoother for you to pass. So once again, thank you all for hopping in. Thank you for watching the replay if you were able to come back and watch. And I'll see you. I'm thinking about doing another live video Saturday morning. So just want to discuss some things. Just want to start doing more live videos besides the homework help. And the live video is free, so you got to be a group member in order to benefit from the extra. Some get our minds wrapped around school, studying with